We're here on the island of St. Lucia as part of a project to understand the deep plumbing system of volcanoes all the way along the Lesser Antilles volcanic arc. An arc that runs for about 700 kilometers from Grenada in the south right up to the island of Saba in the north. The objective of this study is to try and find out what lies beneath the volcanoes. The question is, how much does the deep structure of this volcanic island vary from north to south? Is it similar to other islands we've visited? Or does its position along the arc mean that the deep plumbing system is somehow different? We're here on a field expedition to reconstruct the depths of this volcanic system using the available information from the volcanoes themselves. The volcanoes here haven't erupted for at least 20,000 years, and we can't access the roots of the volcanoes directly from the rocks exposed. We can't drill down. We know that the island is still active, or certainly this area around Soufriere areas, and these are the sulfur springs that tell us that the earth beneath the Soufriere region is still hot. What we have to do is look at fragments of the deeper volcanic structure that are brought up in volcanic rocks. These samples are called cumulate xenoliths. Xenolith means it's a fragment of foreign rock. Cumulate means that the crystals have accumulated, and they testify to much deeper processes. They are coarser grained, they're more slowly cooled, and they give us glimpses of what the structure looks like in the magma reservoirs beneath Soufriere. In particular, we're interested in how long these reservoirs took to form, at what depth they're situated, whether they involve a single pulse of magma or many, many pulses of magma over a long period of time. The Lesser Antilles is a volcanic arc above a subduction zone where the Atlantic plate is dipping down, subducting beneath the Caribbean plate. Subduction not only produces very large earthquakes, but also generates magmas, molten rock, that ascend and produce volcanic edifices, often in a curved arc that we call a volcanic arc. We know that we're situated here above a subduction zone. The subducted slab itself is probably 120 kilometers beneath our feet, but reconstructing the whole 120 kilometers or so is a real challenge. And our objective on St. Lucia is to try and understand better the top 10 kilometers or so of the magma evolution.
I originally started working on super eruptions, huge, large-scale rhyolitic explosive eruptions. I've now switched over and focusing on not what is finally erupted at the surface, but what lies beneath the plumbing systems of these large eruptions. My main interest here is to collect cumulates from the root zones to the volcanism on St. Lucia. By exploring the cumulates, we should be able to find a range of different compositions, different mineral proportions in each of these rocks, which should actually be able to tell us information from each level within the crust. Once we've collected samples from each of the islands, we need to then go back to the lab so we can study them in more detail. By studying the thin sections under the microscope, we can see which mineral phases are within each of the samples. The textural differences between each of these mineral phases and the sequence of crystallization, which we can tell what's going on each of the islands. In this particular sample here, we have olivine, plagioclase, clinopyroxene and amphibole, which is a typical assemblage from the Lesser Antilles.
One of the aims in this project is to look at the thermodynamic data that we have in order to develop new precise geobarometers. Geobarometry is the method that is used to determine the pressure of formation of the crystalline rocks.
And I will try to develop these barometers that will be based on the chemical exchange between the minerals that constitute these samples. First of all, the pressure tells us the depth of provenance of the samples. This is the most important because we need to know how the magmatic system is built beneath the volcano. And so we need to know that, at which depth every kind of rock forms. I will use both mineralogical information and chemical information. I will try to combine the textural observations of these rocks in order to check the validity of the barometers that we are going to use and we are going to develop.
So St Eustatius is one of two islands at the north of the island arc. It's an island of about 21 square kilometers that is distinguished by a very large volcanic edifice at the southern end called the Quill. It's the best place to look for volcanic products, in particular these cumulates, these fragments of the deep crust that the volcanoes of the Lesser Antilles are so good at bringing up.
I'm on the crater rim of the Quill volcano. We're here primarily to look for the plutonic rocks that have been thrown out during explosive eruptions. We're looking for coarse-grained assemblages of crystals that grew in magma chambers some kilometers below the surface of the Earth. Those we find distributed around the flanks of the volcano in pyroclastic deposits, probably moved down by sheet wash events, flooding events, mud flows. The size, variety and pristine nature of the cumulates we found here on Statia have been quite exceptional.
There's no real sign the Quill is coming back to life. The crater has no hot springs, in fact it's a dense jungle, and there's no other indication in terms of ground deformation or seismicity that suggests that anything's about to happen here. By way of a cautionary tale, it's worth remembering that not very far to the south of us, the island of Montserrat burst back into life in 1995 after a very protracted dormancy. Saba is the second of the Dutch Lesser Antilles islands. It's the smallest of the islands that we visited. It's just 14 square kilometers. It's covered in lava flows and dense vegetation, dominated by a single large volcanic edifice that has been dormant since the 1600s, when settlers first arrived on Saba.
I was born and raised on the island, yeah. 8th generation I've been here for.
8 generations.
And the erosion from this area was getting so close to the settlement, the government advised all the people to remove from there in the 1930s, and all the families removed from there in 1934. Everyone got out of there. Right. Yeah, the whole island actually is sitting on a dormant volcano, and it's concerns with some people. You know, we always wonder, are we safe? How with volcanoes, there's no guarantees.
We're coming to the end now of a 5-year adventure looking at the volcanoes of the Lesser Antilles. We've sampled cumulates on every single island, from Grenada in the south to Saba in the north. We have little fragments of the crust from a 750-kilometre long stretch of an island volcanic arc. It will provide incredible insights into what lies beneath a volcanic arc. Why are some islands very large and very active? Why are some islands very small and rather inactive? Why do some islands produce relatively benign lava domes and small lava flows, and others produce devastating giant eruptions? What's the difference between one island and the next? We're uniquely well placed for this study. We're the leading volcanological research department in the UK, one of the leading volcanological research departments in the world, in fact. We also have a range of different tools at our disposal to better understand the process of subduction. Petrology, volcanology, geochemistry and geophysics can all be used to probe the structure of volcanic arcs, with the ultimate goal of understanding why do volcanoes erupt, when are they going to erupt, and how big are the eruptions going to be. I think we're very well equipped to take on the new challenge.